2, this is graph displacement s or distance time t for car moving along the straight road. Copy and complete table 1. This is table 1. Any change, increase, decrease, constant or zero, or no change in distance, speed, acceleration. So we have distance, speed and acceleration. If you look at the graph here, so you can see the first is zone A. Zone A, here we have a curve graph, meaning that we have the increase of this displacement s with the time t increase. But if you look at the, because this is curve graph, meaning if you calculate the gradient of the graph here, the gradient increase. So meaning we have the increase of first, yes, you can increase the zone A, increase the displacement. So here is a increase, right? Increase, right? And at zone B here, you can see also the from zone B here, we have from the final position, this is initial position, we have increase of displacement. So at zone B is also increase. At the zone C, you can see here from the zone C we have the horizontal line graph line here, meaning we have the fixed value of displacement, meaning the value of the C here, at the zone C, what happened to the distance is no change, right? We go to the next zone A for the speed. So at zone A here, because this is curve graph, so meaning we have a curve graph, we have the increase of gradient, meaning increase of speed. So speed is increase, right? And zone B we have the straight line. This is the straight line for the zone B, meaning we have, if you calculate the gradient here, the gradient is constant, the same value or magnitude of speed, meaning we have a constant speed. And at zone C, because the displacement here is the same value, or the distance is not changed, so meaning we have a zero speed, not moving object. And zone C for acceleration, acceleration for zone A, because we have a increase of speed, okay, increase of speed, but the curve graph here refer to the constant acceleration. Constant, why? Because the increase of the speed here is constant, meaning increase speed constant, meaning we have the constant acceleration, right? Curve graph. And the zone B, we have a constant speed. Constant speed meaning we have zero acceleration. And the next, for the zone C here, we have a fixed value of distance, meaning zero speed, also we have a zero acceleration, right? And number B, which zone will the car instantaneous acceleration equal to the average acceleration? Meaning instantaneous acceleration, or AT, acceleration at a certain time t, we have the value of average acceleration. So if you look at the graph S versus T here, zone A, zone B and zone C. At the zone A, we have a instantaneous acceleration, or AT, is equal to A average. So meaning here, if you calculate the gradient of the graph here, the gradient of the graph, the gradient I refer to the M, gradient of the graph, you can use the triangle here. The value of the gradient of the graph is acceleration, the value of the M for graph S versus T is V, but we have a increase of V or speed, if you look at the zone A here, increase, right? Increase meaning we have a acceleration, but the acceleration here, the increase is acceleration here is the constant increase speed or v. So meaning when the speed increase at the certain value of the v velocity or speed, we have a same value of the instantaneous acceleration at any point in the curve graph here at zone A is equal to total or average acceleration, all the magnitude acceleration at zone A. That's why at zone A, instantaneous acceleration is equal to the average acceleration. Yes, that's all. Thank you.